In this study, we propose a hopping robot powered by a parallel elastic actuation with a reactive latch.
Unlike conventional hopping and jumping robots that actuate during the stance phase, our robot uses the entire aerial phase to preload its elastomer and reactively releases the stored energy upon landing. This mechanism increases takeoff speed beyond landing speed without extending the ground contact time. This enables continuous hopping through cyclical mid-air energy storage and passive energy release. High jumps are achieved with lower power demands by using aerial time for leg actuation and efficiently recovering landing energy. This enables the robot to reach a new hopping height record. We showcase a 3.6-meter hopping, surpassing humans, animals and all leg-actuated robots capable of hopping. In addition, the robot is capable of using the ground reaction force to sense its state of motion. When integrated with the hopping controller, the robot can both stabilize itself and follow a prescribed trajectory using only its onboard inertial sensor. In this footage, the robot covered 47 meters in 3 minutes, including navigating 2 short staircases. Besides, the robot is capable of carrying a heavy payload. The 56-gram robot can carry a 39-gram camera. We showcased clips of the robot hopping upstairs and onto a 50 centimeters windowsill while carrying the camera. These outcomes could influence the design of future legged robots, enabling efficient locomotion and obstacle traversal in diverse and challenging terrains.